What's up, chat? What? How I got two people in here? Who watching?
Classic called Sweet Harmony by Liquid.
Yo, what's up, Owen? Yo kan beli bak hari kemasan.
Let me see. I didn't even notice that the premium edition also have a
Good.
Yeah. Have to scan this QR code and then let you rent that. Not money, it's not going to be somebody else's.
Oh. Doesn't look like we have a lab or like a online document to fill out.
Okay. Last week's lab.
It was easy. You just put salt with the water.
Did you finish all of your
Chem homework.
the VR stuff?
Like all the way to Act 6?
No, 3. Aren't you just going to
Act
Act 3?
3?
I was going to Act 6, but I'm pretty sure.
No.
You know,
We can register.
Because then I
now.
think there's like a different, oh my god, there's like a different.
I keep forgetting where to register.
The next one is the stiffer, is Act 1 Aqueous Solutions. I find them fun.
Yeah, they're pretty cool. They're not that fun to people that already do VR. They're not that fun to people that already do VR.
Yeah.
But if you
I think
don't
it's so cool
know,
like, because the VR that I have at my home is like fucking controllers, you know, and it's hard for VR to pick up my hand, so being able to like go and just have
oh yeah, you have your hands. That's
yeah,
pretty
I think
cool.
it's so cool. Like I was able, like the first time, to be able to like unlock my fingers in
Mhm.
VR and pick it up. I was like, damn.
That's crazy.
Yeah, I was not expecting that.
I almost came without this. That would have been like $30 on the thing.
You know, I did Act 3 already.
You did Act 3 already? Can you do like Act 4 too?
There's not Act 4. The next one is Act 1.
I mean, can you do that now?
Actually, you can't.
Like, in my brain, I was saying,
You can't. Dang.
I would probably want to do it after spring break, preferably. I just did all of it up to spring break because
I see.
that's just me.
I've been awake for a while since.
And it's interesting that it's due the week after spring break. Or are we doing lab 6? No, we're doing lab 5.
No, we have an exam next week. That's why.
Oh my god, it's wild that we have an exam next week. I am so shocked.
What do you mean?
Like the fact that we had like not even like 2.5 weeks, like 2 weeks to learn 4 unit or chapter.
I thought it was 3 weeks.
What?
I thought it was 3 weeks.
Because we had it what? It was last. It was what? The 10th, right? Or was it the 17th? It was the 17th.
Of February.
Yeah, right.
Yeah.
Because we learned 2 chapters, then 1 chapter, and we're going up to a whole other chapter to Wednesday and then have the test. That's kind of crazy to me that we like don't even have like.
Yeah, I guess. I mean, I felt like these chapters were way easier. I don't know.
I agree they're easier, but they're way. My issue is vocab, and now like the vocab is really starting to matter.
Oh, I can do it today.
Yeah.
Nice. I do not want to do it today. 10:30 a.m. I'll have to set it up. What's up? Here.
Really? Is it great? I love it. Yeah. It's amazing. They do break really easily though. So keep the packaging just in case you want to return it. I'm guessing you got it from Amazon. Yeah. Yeah. And they're also very finicky. Like it takes, like, if you take one photo, it takes like 30 seconds to 40 seconds for it to get load, and then you can take another photo.
Just repeat. Cool. What? Oh, bro. This is mean. Oh my god. The 6 most abundant metals found in life are the small non-metals we expect from strong covalent bonds and molecules: oxygen, carbon, hydrogen. What does it do? What? No idea what it is. I don't know. I guess we're just taking notes. You guys sign up for classes?
I did already. I already have most of my classes. I'm just waiting for
Yeah.
an override.
An override. Yikes.
Because I'm taking Calc 1 over the summer, and half the classes I'm taking next semester requires Calc 1. So
Yeah. I see.
I'm sure you'll agree.
Are you
in
taking?
there too?
No, I'm in ROTC.
Oh, so then you were able to get early.
Yeah. I know Barrett does it too. You're taking Calc 1 in summer? Like not in university? Or at university?
I don't. That's a great question because I was gonna do it through my community college.
Yeah, that would be fire.
But a lot of them, I'm just scared it's not going to be the calc that they want me to take, if that makes sense. For like, because it says calc 1 for engineers, and the more I look at the one that they.
Oh. Yeah, I guess. But I know you could definitely take Calc 2 for engineers. So I don't know why you couldn't take Calc 1.
Yeah.
But however you can take it. We're taking college algebra right now. I mean, pre-calc right now.
Yeah.
Let's see.
Okay guys, let's get started. So today's class is similar than previous one. So you guys already have this handout on your event, right? So you have to complete the tables on page 7. So before watching, we're gonna watch the video for your today's class. So before watching the videos, I'm gonna let you know some information what you need. So for your activities, you're gonna use these solutions. So we have 3 different types of each. Okay, so this white bottles is authentically carbohydrates and protein and lipid. So before you use, please check the label, and also you need to check it before you use. Okay, and also we have 3 types of the indicators. So indicators in the brown bottles. Okay, and we have gooey materials in PA's bench. So if you need, please take it on. And also we have hot water in front of the classroom. Okay, and after your activities, you need to complete the post assignment and also clean up everything to what you used. Okay, and if you are ready to write down the notes, I can start now. Okay, so let's get it started.
Do you think put this in there?
Oh, yeah.
The arsonists has been identified and found. The bad guys have already demonstrated how they intend to use the chameleon code, but there's something left. Erlingsing hasn't finished yet. He's up to something. The Ornibot found that he's been experimenting with some unusual material. He clearly has further plans, and we don't know what those are. Our job now is to identify what this mysterious material is that the Ornibot escaped with. He previously found that X-ray fluorescence, XRF, was a very powerful tool for figuring out the elemental composition of an unknown material. Ollie performed XRF analysis on the material that the Ornibot escaped with and found the presence of the following odd elements. She's found Ag, silver, I, iodine, Br, bromine, and Cl, chlorine. Let's go back to our periodic table again and remind ourselves that we've been dividing it roughly into 2, into the small atoms which make strong single bonds, and the large atoms which make weak single bonds. And so when they exist as a material, they tend to make lots of weak single bonds, which is what a metal is. So these are the larger atoms, and these are the metals. Because they're larger, they make weaker bonds. We talked about this stuff already. Here we have the smaller atoms. The smaller atoms tend to make stronger bonds. The smaller atoms make molecules. Now in this case we have a metal, silver, and 3 atoms from the smaller non-metal part of the periodic table, chlorine, bromine, and iodine, they're all in the same vertical column in the periodic table, which is given number 17, and all of the elements in this column are called halogens. So if we make a molecule between a metal and a non-metal, of course we expect it to be ionic. So with these elements, we expect to find AgCl, silver chloride, and I've included the charges to emphasize the fact that this is ionic. We expect AgBr, silver bromide, and we expect AgI, silver iodide. These are clearly, obviously all ionic. Generically, these chemicals between silver and halogens are called silver halides. And that will become important later. However, there's something weird, because ionic materials have been detected, but the XRF suggests there's not very much of them. Most of the material is something else. And also, ionic solids tend to have very high melting points and definitely would not melt in a toaster oven. So XRF this time is missing a lot. But we know that XRF doesn't detect all elements equally, and it's these smaller elements up here, the ones that make molecules, those are the elements that XRF doesn't tend to find. So this implies there's a lot of molecular material here, which means we're going to have to analyze it using something other than XRF. If we look at the material in detail, we can see there's a part melted clear plastic part, almost certainly man-made polymer. And there's also a very dark colored gooey part, this part right here. And that's so gooey and soft, it has the appearance of something biological. So let's talk about the atoms and molecules of biology and biochemistry. The atoms of life are a little bit different from the atoms of the Earth, because life relies on the almost infinite variety of biological and biochemical structures we can make by covalent bonding in molecular structures. There are small amounts of metals in the body, but the vast majority of the atoms in the body are these small covalent molecular forming atoms. So the 6 most abundant elements in biochemistry are oxygen, carbon, hydrogen, nitrogen, phosphorus, and we can find those easily on the periodic table. They're exactly where we expect them to be, and we expect these to make molecular structures. There are other elements as well. There's small amounts of metals, sodium, magnesium, potassium, particularly calcium in bones, small amount of iron. There's a very small amount of sulfur and chlorine. However, the vast majority, again, when you look at this pie chart, mostly we have oxygen, followed by carbon, hydrogen, nitrogen, and the others are there in small quantities. And so these atoms are pointing directly at molecular structures. Most of the vast number of biochemicals found in life can be classified very roughly into 4 main types. There are the lipids, there are proteins, there are carbohydrates, and there are nucleic acids. If we look at the elemental composition, the elements, the atoms in these various materials, then they're exactly what we expect. Lipids are mainly carbon, hydrogen, oxygen, and phosphorus. Proteins are mainly carbon, hydrogen, nitrogen, oxygen, some sulfur. Carbohydrates, carbon, hydrogen, oxygen. You see the idea. Nucleic acids, carbon, hydrogen, nitrogen, oxygen, and phosphorus again. These different kinds of materials do different things. This is not a biochemistry class, so we're going to be making this discussion very superficial. And very superficially, lipids are what we're going to call structural. They exist mainly in cell walls. They're also used as an energy source. A bit of an oversimplification, but that's the general idea. Proteins do lots of different things. Perhaps the most common thing they do is regulate biochemical reactions. They do other stuff as well. Carbohydrates are also mainly structural. The most abundant molecular material in the biosphere is cellulose. Think about trees, that's a carbohydrate. They're also an energy source. And nucleic acids, of course, contain genetic information. Very roughly, the way that these different types of materials are distributed in the biosphere, right, the part of the Earth where we live in, roughly 15% of the biosphere is lipids. Very roughly 50% of it is protein. Protein do an enormous number of things. Very roughly 30% are carbohydrates, and only about 5% are nucleic acids, because nucleic acids tend to do mainly one thing, which is carry genetic information. So if this material is a biomolecule, it's not likely to be a nucleic acid because there's not a lot of those. Let's focus our attention on trying to figure out whether this biomaterial is a carbohydrate, a protein, or a lipid. And in fact, that's what you're going to do in the lab today. You're going to detect the presence of biomolecules, and you're going to do it using color. There are tests that we can use which to test for the presence of carbohydrates, proteins, and lipids. The test we do for the presence of a carbohydrate involves iodine ions and iodide. The chemistry of this test you don't need to get into. Suffice to say that a positive carbohydrate test will give a very dark blue color. If carbohydrate concentration is high, this can almost look black. Same thing, there's a color test you can do with proteins. We won't get into the actual chemistry of that test. We'll just point out that a positive test gives a light purple color. And lipids give a sort of unusual color test. There's not a specific color for lipids. Instead, the presence of lipids will give us red globules. And we'll talk more about that later. The other two tests give an actual change in color. The lipid test one's the hardest one to see because you don't get a change in red, you get a change in the nature of the red. We'll talk about that in a little while. So that's how we're going to be looking to see to figure out what this dark gooey stuff is. This stuff looks just like a man-made polymer, which are also molecular. So let's just talk a little bit about man-made polymers. This isn't a polymer chemistry class. We're not going to get into polymers in a lot of detail. Let's just talk about very roughly what they are and how we might distinguish them. Man-made polymers are almost exclusively made out of carbon, hydrogen, oxygen, nitrogen, the standard form of molecular making species. An example is polypropylene, which happens to have recycling number 5, by the way. Polypropylene is a polymer of the molecule propylene. So here is a molecule of propylene. Don't worry, there won't be a test on this. And we get polypropylene when we join many propylene molecules together, usually thousands. So if we join thousands of propylene molecules together, we make a very, very long molecule. So we've drawn a part of it here. This little symbol means it keeps going in this direction. This little symbol here means it keeps going in this direction. And here we can see what happened to the propylene monomers. There's one, there's one, there's one, and another one. So we can see 3 propylene monomers. And, well, there they are. There's a lot of polymer chemistry we're not going to get into today. We're simply going to talk about the way we're going to distinguish them. So if we look at 4 very common polymers, high-density polyethylene, polystyrene, nylene, and polyethylene terephthalate, which doesn't seem common at all until I tell you that that is a part of plastic which is used to make drink bottles. Recyclable water bottles are all made out of PETE. So here are the monomer structures corresponding to those polymers. Here, and we can see that the monomer structures can get quite complicated. Don't worry about this, you won't be tested on this, and here's the monomer for PETE. But all these polymers have different densities. And so we can figure out what a polymer might be simply by measuring its density. And density does connect to molecular structure in ways we'll see as you work through the lab. All right, so what are you actually going to do in the lab? Well, as usual, the first thing you're going to do is clean your glassware. You're going to use a well plate for testing today, so make sure all those are clean. The first thing you'll do is try and figure out the identity of this gooey biochemical material. You're provided with a sample. Don't ask how the Ornibot got enough samples for every group, let's just ignore that for now. And the first thing you're going to do is add some hot water from the lab hot water heater. Then you're going to swirl to dissolve it, and then the goo material will dissolve in the water. And once it's in the water, we now have a solution of that goo material, then we can do some tests. So remember, we're testing for the presence of carbohydrate, or protein, or lipid. You are provided with authentic samples of carbohydrate, protein, and lipid. You will put 20 drops of each of those authentic samples in these positions in the well plate, and then the corresponding positions just to the right of those, you'll add water as a blank solution. These positions right here will tell you what a positive test will look like. These positions right here will tell you what a negative test will look like. So that when you test the actual solution of the gooey material, putting it into these positions, you can then compare what you see in these three positions with the three positive tests and the three negative tests. You are provided with test solutions for carbohydrate. We'll use 2 drops of it. For protein, you'll use 4 drops of it. And lipid, you'll use 4 drops of it. So you can run the positive tests and the negative tests and then the unknowns as follows, and then watch and see what you get. Most of the tests give a very clear change in color. The lipid test doesn't. The lipid test is negative, giving a red solution. A negative test gives a red solution, and a positive test also gives a red solution. But this time in the red solution, you'll see blobs of bright red globules. Okay, so that's what a positive test looks like for the lipid. So you have to look more carefully for that one. It's not a clear color, it's looking for globules. In other words, you're looking for the presence of 2 phases and inhomogeneous solution. The positive test won't give this, it will give a 1-phase homogeneous solution. In fact, all of the tests will give a 1-phase homogeneous solution, except a positive test for lipids, which will give 2 phases. Again, in this lab, you're getting section 3. This is where you're going to write down all the things that you observed today, so you can submit what you learned before you leave the end of the lab. And so for each of these tests, you're going to be asked, what was the color, what was the number of phases? A positive test for carbohydrate will give a dark blue color and 1 phase. And then you can complete the rest of them as follows. And then you're going to do this for the unknown sample, and by comparison, then you'll figure out what the identity of the gooey stuff is. The second thing you're left over with the clear plastic part sitting in the beaker. The next job is to identify it. You're going to compare it to the 4 standard polymers which you are provided with. And you're going to test the relative densities of these standard polymers whose identity is known with the density of the unknown polymer, and see if you can figure out which of these 4 the unknown polymer is based on density. You're going to measure density based on flotation test. You're going to make 2 solutions. One of them is not really a solution, it's just pure DI water all on its own. And you're going to prepare the DI water in a funny way. We could just say, put 50 mils of DI water into a beaker and that's your test solution. However, we want you to actually weigh an empty beaker, add the DI water, weigh it again, and then calculate the density of the DI water using your weight and your volume. Of course, this is supposed to be 1.0 by definition. You almost certainly won't get exactly 1.0. You get something slightly different, and the difference between what you get and 1.0 gives you an idea into the experimental uncertainty here. So this will be one of the liquids you'll use to test, density very close to 1, and then we want you to make a salt solution in water. 13 grams of sodium chloride, 50 mils of water, stir to dissolve it. This will take some time. It won't dissolve very quickly. Then you can weigh and determine the density of the salt water. So these are the two liquids you can test, and then one at a time, you're going to drop a chunk of each of the authentic polymers into the DI water and into the salt water and ask, do they sink or do they float? If the polymer floats, then its density is lower than the solution density. If the polymer sinks, then the polymer density is higher than the solution density. So do all those experiments, one chunk of each polymer, one at a time. As soon as you finish your polymer, put it right back in the bottle that it came from. And then do the same thing with your polymer. Now, your polymer material might not fit exactly into the 50 ml beaker. If necessary, ask the TA for a pair of scissors. You can use a small portion of it. Take a pair of tweezers, stuff it to the bottom of the DI water, let it go, and ask, does it float to the top? If not, it sinks. Same thing with the salt water. Push it down to the bottom of the salt water, let go, and then see if it sinks or floats. As usual, once you've finished all the lab, do the individual. This is not group work. Everybody needs to submit what they observed, including submitting the observations of what you think the identity of the polymer is and the biological material. Submit those in this post-lab assignment on Canvas, and then once you've submitted it, Rodney can then use that information to tell you what he thinks the unknown material is. So after, and only after you've submitted this information, go to this QR code, and Rodney will have a video to tell you what he thinks it is. As usual, of course, you have another post-lab assignment which is due next week. However, we encourage you to work on that in the lab. You can work it with your colleagues, with the TAs. You have more than one chance of submitting that. But again, we urge you to do this in the lab. Okay, that's what you're going to do today. Let's start work.
Lab 6, module 1.
So we start off by doing this thing. Yeah, I don't know. I think this is
Okay, before you guys start, please put the gloves and goggles, okay?
Spare pair of jeans around. Is there anything to like mess me up? Or is it just precaution?
Okay, this side.
We're like the bully Oh, where's like the sample we're gonna It's on now, quick.
How long do I have? 15 minutes.
Oh, they will.
into here. Do we do the drops
Yeah, I guess so.
Huh?
like
The way the world
do the drops here and we do the drops here? So 6 into 11, 2 for each. Yeah, but then don't we do it also on the bottom as well? No, this is. Yeah, but don't we put this?
block.
I feel like we missed it.
Oh, okay.
Yeah.
The dick stuff and what operates on, I think I'm gonna go now. Yeah. I'm not sure.
What's up? Oh, okay. Yeah. I thought we put it in here. Okay.
I think it's just for measuring the water.
Just to measure it?
Yeah.
Okay.
And you put in this beaker.
Oh my goodness. Alright. Okay, so we place the sample in there. And then add 20 milliliters of near boiling water to it.
The hot water is not on yet.
Huh? Oh, yeah. Okay. Fill 3 positions in the well plate with 20 drops. Okay. Well, can we weigh this stuff now then?
Yeah, I guess we could do that.
We have to plug this in? Sorry. Okay, that's fine. We need the plate? Fill 3 positions.
Oh, okay.
Huh?
We weigh that one.
Oh yeah, we weighed this one, yeah.
Yeah, I guess.
Oh, my bad. So you just, the 100 milliliter. So weight of the dry beaker is what?
51.6. Alright, I got those. And we got water.
50. I think so. Wait, does it actually say 51.65? Okay. Alright, sick. And then we fill the beaker. Oh, to 50? Okay. I'll do that.
Okay. I haven't had it use. Have you already got the difference of you know what I mean? Like the change in color. Because that's positive.
That one's lighter?
How do we do?
Yeah.
Okay, we'll stick to the one without the blue sticker, I guess.
Oh shit, wait, do we need to put in these as well?
Keeps fluctuating.
Sure. What's up?
Keeps
I think we have to
fluctuating.
put those in as
So now we...
This is for the salt water.
Yeah, they're the same size, right? They're the same dry beaker.
I mean, yeah, they're the same size.
Okay, so now I fill it up, right?
yeah.
Do we add the weights or? Oh yeah, weight of the filled beaker. Okay.
This one's 49.3.
Oh, use both, I guess. Okay, that makes sense.
Yeah, this is for the salt water and this is for the DI water.
Okay, that one's for the DI water. This one?
So it's DI.
Oh, I mean, okay. So now, can I pour it?
Yeah. 49.3.
So that makes no sense, because you do that once you get your sample. Oh, is it are they different?
Yeah, we're using 2 different ones, so I guess that makes sense. Wait, it was 49 what?
49.36.
Okay. Okay, now I measure this. says 98.
Is that for the water?
Yeah. 98. Is that over the line? You see it? For 50? It looks like it's in between, right?
No, it's right. It's because it's like where the water, the little dome goes, if that makes sense. Oh, yeah.
Okay.
It's 50 or 98.
0.32. And then we just subtract it, right? To get the DI of water?
The solution, yes.
I don't know. 98.32 minus 49.36. It's 45.96.
45.1?
96?
And then we do that divided by the volume, which is what, 50, correct?
It's weight divided by volume? Okay. 50?
0.91.
Yeah, I got that.
92.
Is that what is that in grams or what is that? Is it isn't it like something per
I
gram?
don't know actually. What it could be.
I'm gonna say grams per milliliter.
Yeah.
You got 45?
What? The weight of solution?
Yeah.
95.32 minus 49.36.
I don't know what's right. For 95.32. Oh, you got 95? 98.
Oh my gosh. Alright.
I should have done that.
That's my bad. I'm like really bad at calculators.
Okay, well then that's actually
It does,
concerning because it's supposed to be really close to 1 and then it won't be that close to 1.
it's 0.972.
Okay, guys, the hot water is ready to use. So if you need, you can take it.
Okay, so what's the weight?
48.96.
Divided by 50 is 90.9792.
I'm gonna switch to it.
Yeah. So what do we? It should be 49 something, right? Or 51?
Yeah, 51.65. That's right.
And then do we need to fill it up with water again?
How much salt? Oh, you should have zeroed it. I did. No, you didn't. I wouldn't mind. Like, I can't do it well. Oh, that's weird. It's how many grams? No, it's 51 for that.
Is that for the, how much is the
Okay.
Can you use numbers on the back? Oh, no, I think like
Is the 50?
Oh, I think like oh, this one. Oh,
What was the weight of the filled beaker?
Wait.
Oh, never mind. What?
and then it's all this water.
Yeah. Wait, did we just add 15?
We added 13
13?
grams. But
Okay.
that's not the weight.
That's the weight of the filled beaker, right?
No, because now that it's filled.
Well, what's the weight of the solution then? Is that?
We're not there yet.
Oh, okay. I see. Okay.
So we have this piece here.
Oh yeah.
They said it'll take a long time, or it'll take some
It'll take that. Yeah, definitely. So it doesn't I think we're good now. You guys agree? There's like a little bit on the bottom, but
So will it change the weight?
I don't think so. There's not that much. So it's 113.
Point what?
08.
09?
Oh, yeah, the one we're gonna test.
08. It keeps going up back.
I'm gonna just say 09.
I need that. So.
Oh wow, that's 60.
What?
I think that's 55. What do you think?
Of the solution?
Milliliters.
Yeah, but you added salt.
How many milliliters do you think that says again if you're adding? It's 55? That's what like
Oh, that doesn't look like it's 60.
I'm gonna pour it in here. To see. Are we fine with that?
Okay.
Yeah.
Yeah.
It doesn't look like 60.
It's 55. Yeah. So then
But
61.43 divided by 55. 1.116 grams per milliliter. Alright, so we just did that one. Now let's do this one. I'm gonna put this aside.
okay, cool. How did you do 3? Table 3.
We have to do
I don't know. It's hard.
That's what they did, just in case. So we already did this.
Oh, she went to get this.
So now 1 milliliter is each of these, so it's about 20 grams.
You know, do this. What we're gonna do for this? After that?
That's something like
Where do we do that?
That's this one.
This one? It's 2.3, right? You must complete the individual assignment. Oh, we have to complete the
Then I'll go
individual.
grab the job and put them on the solution.
What?
Double check the tea. Hopefully one's okay.
It's because we skipped part 1.
Yeah, because we were waiting for the water to boil.
Part 3 is part 3 is this one. We have to compare the densities.
Are we? How do we? What? I'm so confused. Oh, we use this. Okay, hold up. We need that in a 100 thing. Yeah. For this. Well, it says. Is it? Yeah, to do the dropping. Okay.
You just like pull it up as soon as
Oh wait, we need DI water too. Oh wait, we have that. Okay. One at a time, drop a chunk of each authentic polymer. Okay. You wanna do that? Okay, where do we get?
It's for sure not a carbohydrate.
Where's the
You get them from the table.
Okay. Where's the authentic polymers? Is it back here?
I do not know.
All right, you got that part. Okay. We're doing the part 30.
Okay. Okay, so I know it's not carbohydrate. It is a protein. I don't know if it's well, no. It's orange. Oh, for pasta. Sorry, I'm sorry. I thought you were asking for like the onion.
Do we have the tweezers? Your other
Dark blue side.
You don't need tweezers.
Huh?
You don't need tweezers.
This?
We don't need it?
Really a different color. This?
I thought we needed to like take
I
it
don't know
out.
like what these are faces.
If necessary.
Negative is like this one. This one like
Okay.
Well, I guess you do.
So then, if it's a positive liquid, it goes through two phases. If it's a negative, it goes through one. And then,
Well, you're doing like CPL.
I think it only goes through one phase. Yeah. One phase. But liquid not two. And then colors.
HTP is PS. this.
So we're doing like CPL. CPL. So it's like the symbol is like not supposed to react.
PS plastic.
So it should be like,
In here?
yeah.
Uh,
Oh yeah.
this thing?
Oh, sorry.
Okay, so you drop each one and then make it sync or something?
Looks good if it floats or not.
Yeah, like
Colors.
There's a hiccup.
So we start with the HDPE.
How do we know what it is?
I agree, so we know like which like true is like symbol of true, and that symbol like
just
nothing.
grab it.
Last time, drop a chunk of each offensive offense into the DIY and saltwater repeat.
So do this. Dog. So do this. Oh, like this.
I guess two phases.
So just put one in each.
This is purple.
Oh, you're lying.
Oh, look, red blob. You see that little tiny thing on the side?
Whoa.
I don't know why the actual positive one doesn't have any. I was gonna actually stir it. Oh, it doesn't. Cool. I don't know how that one does it. It's a look at
No way.
Can it be both?
Pick what? Oh, it must use this one. That one. This one goes farther. Oh, you're lying.
We know for sure it's not color. I could we also know it is protein. That might just be like
Okay, is that too?
a weird coat.
Yeah.
Okay, it looks like it's floating.
I think you'll have to push it down a bit though.
Yeah, that's honestly.
Okay.
I'm just
This is the salt water.
But that will have one. It has one.
Yeah, I'm pushing it down. It's keep going back up.
Okay then, yeah, it's floating.
And it's what?
It's floating.
Okay. Now you do the other one?
Yeah, it's the HDPE.
Yeah. For salt water. So now I do this one?
Yeah. Good. Just pour it.
Okay, so if the color changes, like how
Sorry. Oh, I got one. Okay, cool. Am I pushing it down?
No.
Oh my gosh.
Wait, let me just... I think it's...
So it's two.
Yes, it flowed down. Can we just leave that in there, or
You have to put it back.
we have to put it back?
Yeah.
Okay. Okay, I can put it back. You can try to pour the PS. This one is a PS.
But for the liquid, it's like when you drop the oil in water, it's not visible.
Oh, that's why they're wet in there.
That
makes
is phase separation. So that is two phase.
Oh, so then.
On the others, it's like homogeneous. So that is one phase.
Okay, so
This-
like two phases when you can see like a separate.
Yeah, oil, put that into like water. But maybe because you guys didn't shrink it. Which one is that? For
Okay.
so
Can we try
they,
that again then?
you can try to see the phenomena, or you can go see the bottle liquid. You can see that two layer over there.
Okay.
But I don't necessarily for you guys just doing this.
Okay.
So the two-phase liquid, it tends to have like two phases. The other is just one phase.
Okay, thank you.
Did I just?
Alright, this one's the protein.
Oh my gosh, this has to be the worst lab. Alright. Ready? Yes. You saw that? Oh, never mind. I grabbed it and rolled it down. Yeah, salt water. When you use that?
Yeah, the salt water, the polymer is this one.
What do we use that for?
We need to get it sensitive.
It's like the
Oh, that's the sample one?
Yeah.
Okay, cool.
Wait. Oh, the sample. Okay, I was like, what do you mean?
Okay. Well, that one's sunk.
No way. We dumped this on the same.
Okay. So can I put it back now?
Yeah.
This one, the salt water floats, and then water sinks. That's the hardest work on. Wait, I'm not. Sorry. Sorry, Diego. I'm kind of slow.
Is that
What's up?
But everything else is because it's like
Okay, so we've done both of these. So now what do we do?
so it's like the two bases is like when it's like separate.
The N?
Like it's not a
Another
homogeneous
nylon.
mixture like water.
Is that N?
If that makes sense.
Is N nylon?
Yeah.
Okay, is it? Oh, you already opened it? Thank you. Oh, did I drop one in there? Yeah, it's sunk. Yeah, that's DI water. My bad, I'm not putting it in order.
They gave it for a blue bag, so that's fine.
Wait, we got low points on one of them?
Yeah, we got 11 out of 15.
Oh. Was the normal one with like 16 questions?
Yeah, the one before the last one.
Yeah. The
Before
one.
the VR started becoming a thing.
Oh.
You could.
Oh, you like it?
Can I? Okay, thank you. I just dropped 3. Oh my gosh. I might kill myself. Okay, so
To be honest with you, it was weird. A lipid, we got one wrong, but like not in our classes.
so
Can I see your
in the
list?
salt water, it's floating. I'm trying to drag it down, but
Okay, it's also cloudy. Oh my god, now.
Let's get it.
I literally couldn't do, like,
You have to put it on under the water.
I can't get that class.
okay, you recorded it. Alright.
I can't do anything. Yeah, we just put one for everything.
The one that's like clunky, right? Thank you.
So he loves being in there. It can be right. I think after like getting like a C on the test, it's still somehow getting like really.
What did you do that one? Yeah, this whole conversation.
Okay.
You guys done on the last one?
Is there still one in there?
Yeah.
Oh my gosh.
We need that data.
I decided.
I'm a little colorblind, so.
I was going to I'm gonna try it still. Like, I feel like these concepts are easier.
Alright, nylon is
The
done.
last test. You know, I
Huh?
That goes by
What?
the number.
We do the pairs.
This one?
Yeah, no, I
Oh,
even use
this
it for
doesn't look dense at all.
But
These look like more.
you use the
Yeah, they said it was like kind of like how the solution was
hers
like
are more like the test than
homogeneous and sort of like.
the other person is like if you use that the last being a
So you
subject,
see how this one goes.
use hers to be able to get.
Okay, I'm doing NDI water.
But the other one is what you
Did I
have.
put it in?
Just the fuck out of you, but
Okay, that had to be it. Okay.
So do you guys want to change?
DI water for Peter
yeah,
is
yeah,
let's see.
So you read it like it goes like this, and then it goes like this, and then the macro is this one, and it goes from
Alright. That looks like it's done. Okay, this is apparently like really dense.
so it goes like this. So this first row is black, the second one is yellow, and the third one is yellow.
The nylon and the pedal,
Jeez, this is a lot for
the PS plastic, have about the same density.
Okay. So now
Do the plastic
the plastic. Oh, you have to cut it up or something?
if necessary.
Necessary.
I don't know. I think so. I think that's what that guy did in the video. What does the plastic look like?
You don't have to cut it, just if it's too big.
Oh, like I just grab it and put it back?
Or it's a
Yeah. Well,
Ooh, that's, I think
oh yeah,
that's too big.
yeah, that might be too big.
What? I can't just put it in?
Well, oh yeah, you could try it. Yeah.
Yeah, it looks too big. It looks like it's sinking though.
Oh yeah, it's sinking. Yeah, it's sinking.
But I don't know if that's because.
It wouldn't matter because of density.
Will it disappear? Would it go?
That's
Oh, it's all the way on the bottom.
That's in the DI.
Yes, in a DI. Yo, I lost it, dude. I can't. It's really sunk to the bottom, bro. Nice.
It has to be a P.
What?
It has to be a P.
No! Okay, ready? Okay, so now we do. Huh? That's right here.
Where'd you get the little the sample?
What it was.
Yeah, that
so then
I don't know.
So like I don't know how.
Or you don't know?
Alright.
What it is, I'm
No,
gonna
that you're doing right now.
Wait, I
I'm
don't
gonna do the extra
Oh, you don't know?
exam myself.
It looked like they both sunk.
Well, that's because we only got the little.
Diego.
Yeah.
It looked like it both sunk. Let me try again though. I low-key just pushed it in.
Oh no.
I think it's a P.
I don't know. Where'd you go with this?
Yeah, it sunk. Nice, dog.
It's a P.
Wait, no. Google, what's going on?
Oh yeah.
Hold on.
That's so cool.
Chrome. I use it.
He has it. I didn't record anything.
Where's the? Oh,
Oh yeah, my bad.
did you put it back?
Yeah, they're both empty, right?
No.
What, this has the thing in it?
Yeah.
What? This one has a thing in it?
This one.
Oh yeah. I mean, we can just leave it there, right?
No, you have to
I mean, in here.
Alright. Wait, am I seeing?
Yeah, yeah, it's in there. It's in there. Don't worry. It got me too.
Wait, how do you know if it's because oh shit.
So can I just? Oh, whoops. How is this a sample? Like, what? Is it just a clear thing?
No, it was like a. It had like the.
But like,
You guys.
it had the goo on. It had the goo on it. Was there supposed to be goo on it when I put it in here, or?
It dissolved in the water already. Yeah, all the goo.
Oh, like in here? So like, what's up with this?
It's just like. It's just like on a piece of plastic.
So like, how do I know if I'm like right? It looks like I'm just measuring the density of the plastic.
Yeah. It's supposed to be like a polymer, and it's like.
Oh. Okay. I don't know. Sure. I mean, I guess that makes sense because you just get the density of this and this, and you just add it or something.
We like tried to find out what the stuff is, yeah, and then we
Guys, I don't have any of the data. I'ma just. Wait, are we done with the lab? Like, can we do just the questions now?
Yeah, that's the stuff that we got from the first time.
Okay, I'm gonna just clean up then. Right for now.
Of grams per centimeter. This is grams per centimeter.
Can I just pour this in the sink?
Do you know what? Do you know what one had the highest density?
Which one?
The polymer.
Yeah, it'd be P.
I put the silver because it's the ABBR.
What's that?
It is P for sure. Something with
Yeah, I don't know why I was thinking.
I know it's watched in other countries. It's something different. Oh, I can see what you guys.
He said to do whatever he said to do.
I think it can be used as an explosive.
Just to get the opinion.
This is it, right? So we're finished.
The only point of that is to confirm that.
I'm so sure, but I think that it's
Really just get put away.
Wait, fine, guys, we actually did the lab right for once.
I don't think so. I think
These are the, they need to do the post lab or just like the actual lab?
Should we wait? Let's see. Do you guys want to start that together?
the post assignment.
Yeah.
This was both here, right? Was this?
That was. You can just. Yeah.
Is there a post?
Just like last time.
Post lab, individual solutions.
Got tired by
Let's
it?
post lab. You get what? 2 times? How about we just do mine?
All of those statements
Did you clean it? Yeah.
So I think it's the back.
I was like,
Is someone that stays the same?
but I mean, I can afford it.
I think the
I think the old, those, that was spirit, because that was this was water. Yeah, that's the check. I'll take it. That was right.
Because it's like positive has 2 phases.
Oh.
Was this the goo water?
Do you know if these are right
Yeah, it's the hot water.
for the
water.
that test?
Yeah.
It's a liquid.
I'm gonna guess. I mean,
Okay.
Okay. Thank you.
What did y'all do? No, I have. You're good, but like, what are we doing right now? I just.
I have the.
Post lab.
No, the
Is it individual one?
Yeah. You could copy this. The,
Okay.
Oh, fire, that's not one of the applications.
Did we check our like? Did you check this with the TA?
Oh, I haven't yet. But it looks good.
I think it's fine. I think you're pretty smart. I think.
Thank you.
Yeah, these are confusing.
Yeah, you just scan that, right?
Yeah.
It says after.
Five and 6 is just it's typically
Oh.
Wait, so it had 2 phases, but it wasn't a lipid?
Huh?
It had 2 phases, but it wasn't a lipid? Well, oh, the positive test had 2 phases?
Yeah.
But
Yeah, because like if it was positive, it was supposed to have 2 phases. Like if it wasn't positive.
oh, okay. 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 Nah. Bless you.
post lab just like simple, just kind of just reading what we did.
Yeah. Oh. Hi. I saw you like going. That's okay. Like, people still have my trouble done.
spell y'all's names again?
PRIONND BOOND. Or I guess you just say my last name.
What is it?
EMOND. That's my last name.
My last name? Or
Yeah.
just the last name?
Yeah.
DOW.
Okay.
You got it.
Yeah, I think I got it. Well, I think I put the wrong calculations again.
The lipids gave phases.
Alright, cool. So what was question 4? Thank you. Wait, so what did the QR code say?
It said that it's black and white photograph
Oh,
and it can be digital data.
I see.
The highest density is the 0.84.
Oh, my computer's gonna die.
I was gonna say this bird came from Regency.
So the lipid test gave different phases?
Yes.
Okay. Positive tests.
What do we think we got, guys? Oh, honestly, since I was not bad.
Wait, for what?
The assignment 5.
Oh, you said 6 out of 15?
Sodium chloride.
Yeah, for not knowing what I was doing.
Oh, can you retake it?
Yeah.
Okay, cool.
I wouldn't have cared if, I mean, I would have cared for it. Like, some of this stuff is from the ER experience, yeah.
What was 5?
5.
Was it? Because none of them say orange. And wasn't it orange?
5 is very dark blue, light yellow.
And 6 was very light purple?
6 is very light purple, light blue.
7 was a protein? What am I supposed to do for 8? Is it 1?
8 is...
Or what is it what we got for DI water?
Yeah.
So 0.98?
Yeah.
Do we put the grams per milliliter? Sorry. We put the grams per milliliter?
I don't...
Oh, only numerical. Okay. And then it was Pete, right? For 9.
I think it does. You could do the.
Oh, wait, never mind. Highest density?
You could just get it. You did the lab wrong.
It's P has a highest density, right? That makes sense. Pete. What'd you get for that? The gooey biochemical was a protein? Where's the thing where you like put everyone's names? Is that just the picture you
I don't
take a
think
picture of?
that's normally the post-lab assignment, and I don't think we have to do that this time.
No, like last time we had to take a picture of this with our names.
Yeah, it's like
Oh, you have to like write all our names on it?
Yeah.
the assignment
That's why I asked.
Oh, I didn't write your names. I hope that's not a big issue.
it's for the assignment that's like
Yeah. Okay. Can you retake this post lab? I don't know. I don't know. Is it sodium chloride?
No.
Is it
Sodium chloride.
And it's a protein?
It's a protein, yeah.
And it's the P?
Yeah, it's the P.
Okay. Wait, let me double check. Wait, it's only 5 points?
The 15 one is the one due next week. I just finished that one, but you have 2 attempts to do it, and you get the correct answers after doing the first attempt.
So there's 13. What about the 13 question one? Did you do that?
I just finished it because I was like, mine is really at the time. It really wasn't that hard. And it required, like, I completely
Oh, nice. I got a 5 out of 5.
Alright, see you guys.
I see
See
it.
ya.
Okay. My computer's at 3%, but I'm gonna try to complete this lab. Top of the world, resume quiz. Question 1. Oh my gosh, I can't do this. I'm cooked. Sorry. Oh, brother. Yeah.
Are you doing the homework?
Yeah.
Is it bad or not so bad?
Well, my partner said that it gives you the right answers after you get it wrong the first time. So you can just, yeah, you can do it again. I can do it.
Yeah, I'll try to do it too. So we'll get the answers faster. Let me know which one you're unsure about, and I'll answer the opposite. Alright.
If you are done with using the polymers, please put it back here, okay?
Is it black and white silver halide photographic film?
Yeah,
Oh yeah, that makes sense. Never mind. You go down the energies.
Depends on you check the link, the schedule link for New York. If it's still open, I think you still can schedule that.
Energies of the election status.
That is what I would not
Energies of the electrons increase.
What is the available date for you?
Spiral line, I don't know. It looks like the electrons increase. The molecule particles.
10 grade, 10 points.
How many neutrons does each of the isotopes have? What the hell? What the eight protons, 8 neutrons. Just 10 neutrons. Oh, okay, I see. Okay. C is 6. So 3, 3.
Is that a plastic?
6.
Put that in the beaker, right? Is all that?
7. 7 says 13. Okay, 6 of it. 6 of it is 6. 13 minus 6 is 7. 7. 3. 7 plus. What the heck is 12? I don't know how to do this.
Yeah, forward away.
18 O has 8 protons.
Look like that. The one you draw that. It's still the number 6 because guess what? You're so smart. They try not.
I would just say 7. 26 aluminum. Aluminum has 13. So 13. So 20. What? $26 mg. 12. MG, 12. 12. 12, 10. should be 14. Okay, cool. Most of these elements are.
Most of them I just guessed. I'm just gonna actually take it.
No, which one do you have to? Which ones do you need? Ionic bonding materials.
No. Get the cork, then
Carbon.
you have a little box. Make sure you take it.
13125.
Isn't it just nitrogen? Or oxygen? There's oxygen? Just the oxygen. I don't know. Your second attempt?
Plastic is
My
that.
first.
Oh, okay.
Is the second set?
Because we have both have plastic, right? What?
Oh yeah, it does.
This one has nitrogen.
Yeah.
Which one? PET. For the gooey stuff. Is that?
Correct answer.
Make sure you submit that.
Yeah,
for
it is.
receipt.
Lose control.
Sorry, but you're good. You're good. I just want to make sure that you're not using it as. Yeah, it's the status.
You're right.
All right.
Which also means that we let's use the.
Yeah, no, it's still correct. All of the things, yes. But
Except for
sodium
chloride.
That's halogen. Oh, wait, you said
How did I get 3 wrong? Oh my gosh. The electrons go down. Number 4. The molecule particles move faster at a higher temperature. Number 5. The energies of electrons increase when bonds are broken. Question 6. Lowest density is HDP, PFP. PFP is in the middle, PTEF. Okay. The blue detector measures see a molecule that contains 16. Okay. 8. 2 HDP. 9. Has to be amino acids. Nice. 10. The birds came from the A region? What the? 11. Calcium. Bruh. 12. Oh, nice. I got it correct. 7, 13, 14. 7, 13, 14. Nice. I got 100. Oh my god. Whoa. Forehead.